All right. Day two of our statistics slash analyzing data unit. We're going to talk about box plots. What is a box plot? How can I read a box plot? And then what are outliers and how can I find them from a data set? So, quick little multiple choice question. The length in inches of a box. The length in inches of a box is 3 inches less than twice the width. Which of the following gives the length in terms of the width? So it says the length in inches of a box. Now, the word is very small, only 2 letters long, but it's pretty important because that means the equal sign, essentially. In a mathematical statement, the word is kind of tells you where the equal sign is going to go. So length is the same as 3 inches less than twice the width. So 3 inches less than is kind of a misleading phrase because a lot of students, and it makes sense, that would think that you're going to do 3 minus, but like what number is 3 less than 10? Well, 3 less than 10 is 7 because I would have to take 10 and then subtract 3. So the phrase 3 less than means I'm going to have something and I'm going to take away 3 from it. Okay. Now, if we're talking multiple choice like test taking, right away I can cross out 1, 2, 3 options because those all had +3. Okay. So the length in inches of a box is 3 inches less than twice its width. Well, twice its width just means I'm going to multiply by 2. So I get 2w minus 3, which is option J. Okay. So nothing to do with data or statistics, but just a quick little get your brain moving. All right. So box plot. Okay. We talked yesterday about the 5-number summary. I keep saying yesterday. Minimum is the first number. Then we have Q1, or the first quartile. Then we have the median, which is the middle of the data set. We have Q3, which is the median of the upper half. And then we have the maximum. Okay. Now, a couple more descriptors that I didn't talk about that you will see quite a bit. So those numbers are helpful, but we want to kind of talk about how spread out is this data. Are the numbers closely grouped together, or is it really far spread out? Quite a ways. And so to measure spread, we have 2 different calculations. We have what's called the range, which hopefully you've heard before, but hopefully you remember. The range of a data set is simply a single number, and it's how far apart are the maximum and the minimum numbers. So what's the max minus the min? Okay, so that's the range. And then we also have a value called the IQR, and the IQR stands for the interquartile range. Okay. And just kind of breaking down what this means. Inter means between, quartile. Inter means between, quartile means quartile, and again, range means I'm going to, like, how far apart are they? So the IQR is simply how much bigger is Q3 than Q1. Okay. And it really just, both of those values are a single number, and we will use it to kind of, we can compare different data sets to see how spread apart or, again, how clumped together the data points are. Okay. So we have this 5-number summary up here, but then we also have 2 different values that aren't part of the 5-number summary and something that the calculator won't tell us, but is the range and the IQR, which are just simple subtraction calculations. Okay. And so the reason we use a 5-number summary is to produce what's called a box plot. Okay. Sometimes called a box and whisker plot. What it is it just shows the 5-number summary in a single graphic. And so the way this works is we have 5 markings on a box plot, and though each of those vertical lines shows one of the 5-number summary, and it goes in the exact same order. So that right there is the minimum. This would be Q1. The median is drawn as a line in the middle of the box. Okay, and Q3 is there, and then the maximum is up there. Now, So if we wanted to say what's the minimum of this data set, it looks like the minimum is 2, just the fact that, it's right in between 0 and 4 there. Looks like Q1 is maybe 5, the median is 6. I'm going to say 9 for the Q3, and then 14 is the maximum. Okay. So I figured out the 5-number summary without actually having the numbers in front of me, just based on the picture there. A couple more things that if we were diving deeper into data analysis is 50% of the data is inside the box from Q1 to Q3, and then 50% of the data is outside the box. 25% is above, 25% is below. So that's kind of where the quote-unquote whiskers come in. So 25% above, 25% below, and then 50% is in that middle of that box. What is the range, or what are the range and the IQR? What is? So for the range here, we know that range is max minus min, which is just, is 14 minus 2. So the range of this data set is 12. And then the IQR is Q3 minus Q1, which is 9 minus 5, which gives me 4. So if you were asked what's the range of the data set, the answer would be 12. And that tells, again, the distance from min to max. And then the IQR is 4, which is the distance from, or the space between Q1 and Q3. Okay. So if I wanted to create a box plot, you could either find the 5-number summary of this that data set by hand, but I'm going to go ahead and type into the calculator. So just a reminder, we hit stat. The stat button is what we're going to use anytime we're talking statistics or data. Hit edit, and then I'm just going to type in this data here. So 1, 3, 3, 8, 8, 8, 10. If you mess up, you can just go back and overwrite it. 12, 15, 15, 16, and 18. Okay, so I'm going to go stat, over to calc, one of our stats, I hit calculate until it tells me the information I want, and then I scroll to the bottom. So we have the minimum is 1, the median is 8, max is 18, with Q1 being 5 and Q3 being 15. So what I'm going to do is I'm just going to draw a little tick mark or a vertical line at each of these 5 numbers. So I have 1, 5 is the first quartile, 8 is my median, 15 is my Q3, and then 18 is the maximum. So 18 is right there. Okay. So I have 5 equally sized vertical little dashes. And again, the box portion of the box plot runs from Q1 to Q3. If you want, you can label this median Q3. And then the whiskers, at least that's what they were called when I went to school, or old man, are, you just draw lines from the box out to the max and the min. Okay, so that's how we can create a box plot. Again, you could find that 5-number summary by hand if you wanted, but I prefer to use the technology since it's available. All right. So the last little piece we're going to talk about is an outlier. Now, you've heard outliers before. Outliers are extreme values that are way higher than the rest of the numbers, or way lower than the rest. We're going to actually put some math to what an outlier is, so we can decide kind of mathematically if a number is an outlier or not. Okay. So to figure out whether or not a data point is an outlier, we're going to calculate what are called the fences. Okay. And essentially what we're doing is we're going to figure out, there's going to be some points. Okay. And this is just generic, so you don't have to go back and mark this. There's going to be some amount after Q3 that we're going to draw. We're going to find what's called a fence. Okay. and it's going to be some distance outside the box. And it's basically going to say if you go past those fences, either above or below the lower fence or above the upper fence, then you are classified as an outlier. Okay, so these fences are kind of like the borderline number that if you're above or below it, then you are considered an outlier. And the way we're going to find these fences is we're going to take 1.5 times the IQR. Okay, so we're going to take 1.5 and multiply by whatever the IQR is, and then we're going to add that to the upper fence, and we're going to subtract it from we're going to add it to the third quartile to get the upper fence. And then the lower fence is going to be that number subtracted from the Q1, and that will tell us like what threshold number is at to determine whether something's an outlier. The last 30 seconds were not the best description I've ever had in my life. I'm not going to go back and edit it. Let's just see an example, and hopefully it'll make a little bit more sense. Okay, so I'm going to calculate whether or not we have any outliers in this data set. And you might, if I look at the smallest number I have is 18, the biggest number I have, that's a lie. The smallest number is 16, and the biggest number is 54. So the question is, are either one of those going to be outliers? And you might say to yourself, oh, I know it's going to be 54, or yeah, both of them, or neither. But here's how we're going to actually calculate this. Okay, the first thing I need is the IQR. Okay, I need to know what the interquartile range is. So I'm going to take this data and enter it into my calculator. 19, 21, 18, 18, 4. If you mess up one number in this, then everything is going to get thrown off. 54, 20, 22, 23, and 17. Okay, so I go stat, over to calc, calculate this. I get Q1 is 18, Q3 is 22, so the IQR is 4, because that's how far apart 22 and 18 are. Okay, so then what I'm going to do is I'm going to take the IQR and multiply it by 1.5. So I'm going to take the IQR 4, multiply by 1.5. That gives me 6. Okay, that number 6 is pretty important. What that basically says is if you are 6 above Q3 or you are 6 below Q1, anything further than that from the quartiles, you are considered an outlier. Okay, so my lower fence is going to be Q1, which is 18. I'm going to subtract 6. 18 minus 6 is 12. What that means is anything lower than 12 is considered an outlier. So do we have an outlier? Well, there's nothing lower than 12 in this list, so there is no outlier yet. And then if I calculate the upper fence is the same idea, except I'm going to take my third quartile, or my upper quartile, which is 22. I'm going to add 6 to it. That gives me 28. That means anything bigger than 28 is an outlier, or anything less than 12. So the only number in this list that fits that description is 54. So 54 is an outlier, and that is the only number we have. That's an outlier. Now, we're not going to get into in a stats class. You would say, okay, now what happens if we take the outlier out? How does that change my 5-number summary? We're not going to mess with that at all. We're just trying to identify here, do we have any outliers in a data set? Okay. So pause here, see if you can replicate that and see if you can figure out, are there any outliers in this data set? All right, so stat calc, clear this out. I have 90, 100. A lot of times outliers jump out at you, and so 40, as I'm typing it, 40 seems crazy small. So it's probably going to be an outlier, but I just want to make sure that's the only one that we have. 92 and 182 seems pretty gigantic, so we'll see. Okay, so I'm going to go stat over to the 1-bar stats. go down to here. So I get Q1 is 90, Q3 is 110. So the IQR is how far apart are those numbers, and that's 20. 1.5 times the IQR, or 1.5 times 20, is going to be 30. So 30 is kind of my magic number again. If I'm 30 above Q3 or 30 below Q1, I'm considered an outlier. So my lower fence is 90 minus that magic number 30, which is 60. So anything less than 60 is an outlier. And sure enough, 40 matches that description. And then if we switch colors here to get the upper fence, I'm going to take Q3, which is 110, and I'm going to add 30 to that. So 140 is my upper fence, and it looks like 182 is the only outlier there. So 40 and 182 are both outliers in this data set. So hopefully it kind of made sense. Once you calculate those fences, it's a pretty quick scan and see, do you have anything higher or lower? So Boxplot, or EQ is what is, or how can I display data using a Boxplot? Boxplot shows the 5-number summary. 5-number summary. On a number line. And then outliers. Outliers are more than 1.5 times the IQR away from the quartiles. I'm going to say outside. Outside the quartiles. Don't need a period. Okay. So that's part 2 of 11.6, and then part 3 we'll talk percentiles, which is something you've also seen before.